Hello. Today we're going to talk about homologous structures. Homologous structures are often somewhat confusing to a lot of people when they first run into them. So we're going to go over them piece by piece in order to understand them better. So I'm going to share my screen with you, and we're going to look at what they are together. So homologous structures, what are they anyway? You might look like this little guy before you learn. Totally confused. So, an easy way to understand scientific terms is often to break them into pieces and find out what the individual pieces mean. Much like when you begin to learn to read, and there are smaller words within bigger ones. So, homologous is made out of two words: homo, meaning the same, and logos, meaning proportion or form. So, if they're the same form, and then we have the added adjective structures, except it's really a noun, but it's describing it here, then we know that they're going to be something with the same form, and it's going to be structural. It's not just going to be an idea. It has to be matter. So we're going to look at that definition and see if we can use it to help us determine what is homologous and what is not. I will have 4 pictures on the next slide, and I want you to take a moment to look at them, and using this definition, try and see if you can figure out which ones are homologous structures and which are not. Okay, so looking at the 4 of these, we seem to see a trend. The damselfly, the batwing, and the airplane, or jet, all have to do with flying, whereas this is the human arm. You can't fly with a human arm. So we would originally, perhaps, want to group those together and say that the human arm is non-homologous, they're homologous. What we need to know is that just because something is used for the same purpose doesn't mean they're homologous. Being homologous has to do with how it's built up, where it came from. So, in this case, the damselfly, its wing helps it to fly just like any other wing, but it doesn't really look very similar to the batwing. It's flat, but that's really the only similarity. There are veins in here. It's made out of chitin, whereas the bat, it's made out of skin stretched across bones. So those two are non-homologous with each other. So if we take the bat wing and compare it with the human arm, we actually see some interesting similarities. This bone here, at the base of the bat's wing, is the same as our upper arm bone. And also, it's attached to a longer bone, like ours, and then to some small connecting bones, like we have in our wrist, and then long fingers. So they're the same basic structure, even though they're used for very different things. We obviously can't fly, but bats can. We have the same bone structures. These two are actually homologous with each other. Now, if we look at the jet, it can fly, but we remember that the damselfly, even though it could fly, wasn't homologous with these. And they're very different structures. None of them seems to match, so that is not a homologous structure either. So the confusion about what a homologous structure is often arises from the term not being explained well. It's explained using circular reasoning, which is reasoning that says, well, it doesn't really explain it. It just goes back to where you started in order to explain it. You can't separate them and find out what it is, the actual definition. Here are some examples. So if you were given a math equation that said a plus b equals b plus a, you know that they're the same, but if you're given a plus b, it doesn't tell you anything about a or b, and You just know that you can add them together. You don't know what the result is, so you don't really have a definition. Or a lot of kids will ask their parents, why are things made the way they are? And often the response is, because that's the way they were made to be. We don't answer the question, we avoid it, and just state what they asked, but not as a question. So that would be another example of circular reasoning. And the way circular reasoning is used for homology or homologous traits is we say, okay, there's a common ancestor, and then this modern descendant has something in common with them. But that was because they had a common ancestor. And the modern descendant comes from the common ancestor. And you just keep going back and forth. You can't stop the process. And that's the problem with circular reasoning. So I hope that you understand homologous structures a little better now. And don't be like this map. Don't use circular reasoning saying something is because it is. Really understand the term. So that's all I have for you today, and I hope it helped you out. Thank you very much. Bye.